Hello guys. First of all, thank you for coming for my presentation. Um, I hope you can all hear me well. So we can start with the presentation. Just a second. Can you see my screen?
Yes.
Okay, thank you. So we'll be talking about Project Ember, what it's all about, and first of all, who am I? My name is Sakib. I'm currently working at Whitehead Gaming as a consultant. I have my own company called Sakib. So the Project Ember focuses on readability and usability of Java. So Java is criticized for being verbose for many years. And a simple point class with two fields can be a kilometer long. You have to implement two-string hash code and all those boilerplate methods. So the Project Ember delivers vars, multi-line strings, switch expressions, pattern matching for instance of records, seal types, and in the future the goal is to implement full pattern matching with deconstructors and other good stuff. If you have time, you can follow along with my repository that I sent in the messages. There are demos and for each of these sections. So first feature is local variable type inference. So the most significant quote from the job for me is that some users imagine type inference to be a form of mind reading rather than an algorithm for constraint solving. So it's not a magical thing, it's just something that compiler does for you automatically. Before you had to explicitly specify the type of the variable, but now compiler can infer the type of this variable list that's an array list of string. You don't have to repeat it twice like before. And in this other example, we can see a bit more complicated expression which uses the information that compiler has seen before to infer the type of this list.stream expression. So there are some rules in the Java var implementation. First of all, it's local. It applies only inside a method or a constructor body. That's a difference between, for example, Scala and Kotlin, which are using the var or val keyword for fields also and constructor parameters. So the type of variable is inferred. You don't have to type it. That's the whole idea of var. Another interesting thing is that identifier var is not a keyword in the Java language. It's just a reserved type name. So you cannot have a class, for example, named var. Every expression has to be initialized. It cannot be null because Java compiler doesn't know what the type of null is. Here are some examples which are very useful, at least for my day-to-day job. Especially when you're iterating through the map entry set, you have to specify map.entry and all those generic types. Now you don't have to do that. You just specify var entry and move along. Second example is dealing with cumbersome type names like input stream reader or buffer reader, etc. You can also use var inside try with resources expression. It's much more readable because the only important thing here is buffer reader types before it are just not that important, and we don't have to see it in our source code. It's much easier to read it. These are some examples that are not working. So the compiler cannot infer the type of this expression, although it probably could with some more effort. So, yeah, many people that are hardcore Java users would object to this addition to the language. It's a bit controversial, but as all other language features, it can be used for both good and bad things. Bad programmers will always write bad code. Yeah. So now we can see a little demo here. It's just handy to. It's easier to make a new variable. You don't have to when you don't have to type the whole type. It can have some surprising behavior. For example, here list with array list with diamond operator will return you a list of objects, array list of objects. It sometimes wouldn't be what you have expected, but now you have to explicitly type the declaration on the right-hand side. If you wanted an array list of strings, you now have to explicitly say it. But on the left side, you don't have to. Now it doesn't compile when you try to add an int. Also for consistency, they added the var keyword in lambda parameters also. So just so you wouldn't complain, it's not consistent with lambda. Here we can see that var is indeed behaving like a type, because you can annotate just a type with this interface, with this annotation, not null. Type use or parameter. Yeah. Also, I prepared a decompiler demo here with the decompiler called CFR, and we can see how it is behaving in a nutshell under the hood. So the compiler will infer the type of ABC as a string and int as an integer, and this lambda thingy on the end. Okay, so if there are any questions, you can interrupt me anytime, and I'll stop and try to answer it. The next feature is text blocks, or as we normal human beings call it, multi-line string literals. Before you had to type and concatenate a string with plus or string.format and other stuff like streams. So now you have this at your toolbox. Multi-line strings are denoted with triple quote, and it has some pretty complicated rules of how to remove the incidental white space before the string. So the algorithm goes as it follows. So it takes the leftmost line, ignoring the first line, and it chops off the white space before that. So for example, here we would have just one space before select, and here it would have no spaces. So these are almost all the rules. Of course, you can use a single quote instead of escaping a quote. You don't have to type /n or /r. Also, all lines are normalized to Unix style /n line feed. Incidental space is removed. Also, the space is removed after the non-white space characters here. For example, if you wanted to type some markdown and have two spaces to denote a new line, you can't do that with multi-line strings unless you use a escape character, of course. So there are two new escape characters in Java. The first one is for creating a single line, but expressed with a multi-line string. For example, you can do that in Bash. Also, when you add a slash on the end of line, it will just remove that new line character and concatenate the whole line into one. We can see an example in the demo that I will show. And another escape sequence is for non-trimmed space. As I mentioned, if you wanted to write some markdown, you have to explicitly say, hey Java, please don't remove this space, I need it later. And yeah, so the demo is here in this class. This is just a simple multi-line string example. The first one. The second one is showing concatenating it to a single line, and the last one is non-trimmed space. This is the first example. You see that all the white space is removed, and the second example is showing the concatenated line. This is the first one, this is the second one, and third one. And the last one is an example where you want to preserve white space on the end of the line. So that's all regarding the multi-line strings. You can see for yourself how the compiler interprets this under the hood. This is the first example. It just adds /n. For example, I'm on Windows. This is probably in the source code /r/n double character, but the Java compiler compiles it to just one n. So you can have consistent behavior on multiple platforms. So the next feature is switch expressions. They are available from JDK 12 and above. So the current switch statement is really a minefield for bugs to show up. For example, you have to declare a var before switch statement and assign it in each case. And you can also forget to assign the variable in one of the cases. You can forget a break semicolon somewhere. Did I forget the default? You cannot. And also the one peculiarity is that you cannot have the same variable name in two cases because of this fall through without break. So the switch expression has a similar syntax, but it uses a single arrow like in Lambda. But this here is not a Lambda, it's just a similar syntax to Lambda. In each case, you have to return an expression. Compiler will warn you if you just have a semicolon here, for example. And you can assign an expression like a ternary operator. You can also match on multiple values. For example, here, Monday, Friday, and Sunday. The comma is treated as an OR expression. So the rules are there is no fall through. You don't have to type break anymore. Compiler does flow analysis for you. It forces you to have an expression returned in each case. And of course, if you specified the type in the variable, you have to return the same type in each case. Or you can throw an exception. For enums, a default branch is not required. Compiler inserts throw exception statement for you. And the last rule is you can use yield keyword when you have multiple statements in one case. Now we can see the example. This is the ordinary switch statement where I forgot to insert break here, and it matches the other case, it falls through, and it prints 5 also. when we run this example, yeah, we can see indeed that it prints 4 and 5, just because I forgot this break here. Now if I fix it, it should work. Also, you cannot have same variable in 2 cases because compiler will complain and tell you that variable x is already defined in this scope. It doesn't let you do that because if you don't have this break, this variable x can be seen in this other case also. Now we can see an example of new switch statement mechanism. So we match on the day of the week enumeration, and if we have Monday, it will return just 0. This is just a simple example. It doesn't do anything. And in the default case, we have multiple statements, and we have to use the new yield keyword. It will return the variable k from this expression. Yeah, that's basically all regarding the switch expression. And the last example here is the exhaustiveness. If you are missing some of these cases for enumeration, the compiler will warn you if you are missing one branch. Switch expression does not cover all possible values. And we can see now in the decompiler how it's all compiled to ordinary Java. This is the switch expression example. The compiler does basically what you would write manually. It declares a variable int n, and it assigns it in each case and inserts a simple break. We can see also for the Boolean example enumeration, it inserts a throw incompatible class change error. For example, if you compiled your code with this version of enum and you just update the jar of the new bool version, for example, someone added a fuzzy value, of course, you would also throw an exception in your default branch. So yeah, that's all regarding the switch expression.
Hey, Sakib, I have a question. Can you please go back to the switch, that example?
Okay.
So because on line 62 you have a var keyword.
Yeah.
It's possible to on line 64
yeah.
the false case.
Yeah, you can return a string, for example, and compiler will infer what's the common supertype of these two expressions. That's usually not what you intended to, but it's best to tell the type explicitly, and then compiler will help you, as I said, with the flow analysis and tell you that the type is not correct.
So if you returned the var keyword up there, so the infer type will be object.
It would not be an object because it basically calculates the supertypes of these two. This true should be cast to a boolean with big letter. How do you say that? I forgot. And then it calculates the least common supertype of these two expressions. It's a bit complicated, but basically that's what it does.
Okay. So I don't know. I'm not sure at this moment, but I guess the common supertype for boolean and a string
should be an object.
I don't know if there is something more specific than that. Okay, that was my question. Thank you.
Yeah, it's a bit complicated, but
I guess, yeah.
That's all it does.
Okay, thanks.
Yeah. So the next feature is pattern matching for instance of. It's available from JDK 14, and it basically does what you would do in this example. When you're checking if an object is an instance of some class, you usually cast it in 99% of cases to a variable. And now you can do it in just one line if object instance of string s. And compiler introduces this new variable s in the next block of the if, only in that branch. But it gets a bit more complicated. Compiler does more work for you if you have some negation. Here, if object is not an instance of string s, the s variable would be available in the else branch and not in the first if branch. And it also works with AND operator and OR operator. We can see that in the demo. Here are some examples. Here we are checking if object is an instance of string, and then it would just print out the string length. I used random here to really show you that this is sometimes working, sometimes not, because the variable here is object and we are matching in the runtime, is it a string or is it something else. Here we can see in the second run that this random returned a string, and now it's indeed a string and we print out its length. If you have some complex conditions, like here we are using if collection is an instance of ArrayList, and we introduce a new variable list, and then we check if that list contains an empty string, and then we check its size, etc. So compiler introduces this new variable list immediately here after this character, and we can use it after this AND operator. That's not the case with the OR operator, because these are disjoint conditions. This collection can have size greater than 5, but it does not have to be an array list. We can see here, if we uncomment this line, we can see that list is not available in this scope because we are using this OR operator. And it's also available in lambdas. You can do some handy expressions with instance of feature. Now we can see in the decompiler how it's all compiled to ordinary Java. You have all these in my repository if you want to play with it later. It basically does what you would do manually. It just inspects if this object is in instance of string, and it casts it for you. In this AND example, it's a bit more complicated. It inspects if this abstract list is an instance of ArrayList, and then in the same expression, it assigns the list variable to and casts it to an ArrayList. Yeah. And then you can use this list variable in other expressions involving this complex condition. In the last example, we can see it does basically the same in the lambda. That's all regarding the instance of pattern matching for instance of. The next feature is records. This is one of the most awaited features in Java. It's basically Scala's case class or Kotlin's data class or Lombok's @value annotation. It's basically a compact syntax for shallowly immutable data. Shallowly immutable means that all the variables that you put in the record are final, and also a class record is also final. It cannot be extended by any other class. As I mentioned at the beginning, we would need at least 30 lines of ordinary Java code to implement this functionality today. So the benefits are you have less boilerplate, it's much easier to read. You get accessors or only getters for each field. You get for free hash code and equals. You get a sensible toString implementation. But of course, you can override these methods for yourself if you want to. It's also trivially deserializable. We all know that Java serialization is pretty bad today. The main cause is mutability and extending classes. As I mentioned, also it's implicitly a final class, and if you have multiple constructors, they all must delegate to another constructor. We'll see that in the demo. There are some drawbacks for record classes. You cannot extend a class, but you can implement an interface, of course. You cannot introduce new fields in the body of the record class. These are the only fields that this class can have, and they are all mentioned in this primary constructor. And last but not least, it's less lines to commit. So no more of that. Here we can see a simple example of a record. It's called a person, and it has two fields basically that are also parameters to this main constructor called person. And if you want to do some validation of arguments, for example, if you want to check if this name is not null, and if it is null, then throw an exception, throw a new runtime exception. You can do it in this much conciser syntax than before. So yeah, here you can validate your arguments, and if you want to have another constructor, you have to delegate. You have to delegate it to another constructor. So this is how you would do it. Now you have this constructor and this one here. But in this one, if you don't delegate to primary constructor, the compiler will warn you a non-canonical constructor must delegate to primary constructor. Here is the main part. The syntax is just the same as for ordinary class. You write new person and give it its parameters. You can print it out and see that toString is indeed implemented correctly. You can see that equals compares these two record objects structurally. So it compares this string with this string and this field with this field recursively. Yeah. Also, hash codes are the same, and you can see here that you have these accessors without the ordinary get something in JavaBeans specification. Also, a nice feature is that you can create a record class inside a body of a function. Here we can see that this helper record is defined inside main method, and you can use it like a utility, or for example, if you do stream and mapping, shuffling stuff and that stuff, you can use inner records. demo for this one. The compiler. Here we can see that the compiler creates a final class that extends a marker class called record. You can use reflection to inspect if a class is a record, etc. Do code generation analysis. You would write this all by hand, but now you can define a record in one line. There's not much to it other than this. And the last, and for me the most complicated feature, but very useful, is seal types. They are just released in a...
Sorry, just one question regarding the records.
Yeah.
You mentioned that they are shallowly immutable.
Yeah.
What does that exactly mean? Shallow.
Shallowly immutable means that only the reference that you specify here, for example, if you have a list of strings here, this reference is immutable. It doesn't mean like in C++ that you get freezed object or something like that.
Yeah, I got it.
Yeah, that's all. Thank you, that's a good question.
But that is also regular immutability.
Yeah, it's regular.
If you have a final, I don't know, list, you can mutate the contents of the list.
Yes, that's exactly. But you cannot mutate the reference. For example, when you set a field in a class, you just switch the references, but you cannot do that here.
Yeah. Okay. Thanks.
That's why it's called shallowly immutable. Only the reference is immutable. Yeah.
I got it.
The last feature I want to present you is the seal types feature. Now you can restrict which classes or interfaces may extend or implement a class or interface. Currently, you can make a class or its constructor package private, so it can only have subclasses inside that same package, but users cannot use that supertype, only the subtypes. For example, abstract syntax builder inside a Java library. There are two ways of declaring a seal type. First one is specifying all the classes or interfaces in the permits clause. So here we can see that we have a sealed class shape that can only be extended by circle, rectangle, and square. This can be in other files, in other packages, etc. The other way, and it's a bit more concise for me, it's to just include it in the same file, and compiler will figure out what are the types that can extend this class shape. Any other class that you make or someone else makes cannot extend shape even in the runtime, because the JVM will throw an exception if someone tries, for example, with reflection to implement this class. So classes are not always meant to be reused. Sometimes they form a closed world. For example, if you have option interface, you can have two types that are extending it, sum of t and none. That would replace the optional class that we currently have in the Java library. Another example is an either type. So you can have either an error type or the correct type, the right one. So you would have two subtypes called left and right. Left is usually used for denoting an error. For example, if you have, it's similar to future type, where you bury your exception inside the future. But here you would do it explicitly with these two subtypes. Also, if you have a compiler, you have a finite number of types that you are using, for example, an AST or something like that. and also you can forbid user to extend your shapes and mess up with your GUI library. Yeah, so these are just my thoughts. Enum versus sealed hierarchy. When you have an enumeration, you basically have a set of values to use with this type or enum. And with sealed types, you basically say to your user, hey, here's a set of types that you can use with this type and nothing else. Also, for functional programming lovers, we now will be able to have algebraic data types in Java. Records are basically product types, and sealed types are sum types. Yeah, another rule for the permits for the classes extending a sealed type is that they have to be one of these three. It can be a final class, it can be further sealed type, and it can be non-sealed. That means that it can be extended normally. And also, if you compile your code against a sealed classes hierarchy and then just update your dependency, you can get a incompatible class change error. So as I mentioned before, JVM runtimes checks the list of permitted subclasses. They are explicitly written in the class file. And then, yeah, we can see the demo of sealed types. Here's a simple hierarchy that I showed in slides. We have a simple sealed class shape and these three classes in the same file that can extend this shape. The current limitation of Java is that you cannot have multiple public types in a single file. And that means that these circle, rectangle, and square can only be used in this package that's called sealed. You cannot use it outside of this package. I think that this limitation will probably be lifted, and in the future you can write multiple classes basically in the same file that will be public. Here's a simple demo showing the shapes hierarchy. We just add it to an array list and inspect with the new feature pattern matching for instance of if a class is a circle, a rectangle, or a square. Currently, compiler does not check reachability or exhaustiveness. In the future, it would be nice if we could just remove this expression and compiler would verify for us that indeed it cannot be an else branch because we handled all the cases. It cannot be anything other than circle, rectangle, or square. And also you cannot have an anonymous class like with a regular class. Yeah, the last example is this shape2 hierarchy, which is basically the same as the shape hierarchy, but only using the record feature. And we can see with the decompiler, basically the CFR is not yet updated for Java 15, so we used ordinary Java P just to see that indeed the information about permitted subclasses is written in the class file. So the JVM can inspect if this type shape is indeed one of these three. Yeah, so that's all. I have this cool project called Jabble. The Android developers cannot use, as far as I know, JDK 9+, but with this plugin you can use syntax for Java 9 till 14, and this plugin will compile it to Java 8 bytecode. It's basically a compiler plugin that plugs into your build process, and then you can use switch expressions, text blocks, vars, etc. Another useful link is this Java features matrix, where you can compare the differences between, for example, Java 14 and Java 11, etc. You can explore their APIs, specifications, and that stuff. So yeah, that's all from me. If you have any additional questions, I will be happy to answer them. Yeah.
Could you please paste that link, that matrix here in our chat?
Yeah. Also, I forgot to mention you can see my presentation on my website Sakib Hadžiavdić later. Yeah. Are there any other questions? Or just sealed. This is what I mentioned before. For Java compiler does not yet check the exhaustiveness in the switch expression. This will be implemented in the future. You can pattern match basically on the type of a variable in your switch. You can say if it's a circle, do that. If it's a rectangle, do that, etc. Yeah, so that's all, folks. Thank you for coming.